Hello students, in this video we'll discuss experiments, outcomes, and sample spaces. An experiment is a situation where there's an unknown outcome. We can combine two substances together and see what happens, and it might be uncertain what the substance that outputs becomes. So an experiment is something, it's a situation where the outcome is unknown. We can think of an experiment as a roll of a dice, for example. So example, a roll of a die is an experiment. The outcomes, whose outcomes are 1, 2, 3, 4, 5, and 6. Another example would be a draw from a deck of cards is an experiment. If you draw from a deck of cards, you don't know what the outcome will be, whose outcomes are, well, you can have the ace of clubs, the 2 of clubs, etc., the king of clubs. You can have the ace of hearts, the 2 of hearts, the king of hearts. You can have the ace of diamonds, the 2 of diamonds, the king of diamonds. You can have the ace of spades, the 2 of spades, the king of spades. And so there's a total of 52 possible outcomes. So you can think of all sorts of other sort of experiments. This you can say a temperature measurement is also an experiment. And the outcomes, whose outcomes are anything in the interval 0 Kelvin all the way up to positive infinity Kelvin. You can have as much heat as you want, but you can go down only as low as 0 Kelvin under most physical assumptions. So we can see that outcomes can actually be an interval, right? So more conventionally, we write this as 0 to plus infinity. And so we can see that an interval is the set of outcomes, whereas over here you have a discrete set of outcomes. So these are discrete. Over here you have 6 potential outcomes. So this is discrete set of outcomes. This is discrete set of outcomes, and this is a continuous set of outcomes. And so the space of outcomes, so definition, the collection or set of outcomes is called the sample space. We'll denote the sample space sometimes mathematically as S. So for example, the sample space of the roll of 2 dice will be S, and you can get a 1 and a 1, you can get a 1 and a 2, you can get a 1 and a 3, etc., all the way up to a 6 and a 6. So a total of 36 possible outcomes. So the sample space has size of 36. And now, once we have the idea of a sample space, we can talk about the approach to defining probability. And so we can consider this. So if we wish to define the probability of an event happening, so the probability of an event or an outcome happening is, mathematically, it's going to be the limit as n approaches infinity of the number of times the event happens over the number of trials. So if you perform an experiment 100 times, and you only find that 10 of the times the event happens, the approximate probability is 10 over 100, or 1 over 10. If you perform the experiment 1,000,000 times, and it happens 10,000 times, then the probability is 10,000 over 1,000,000, or 0.01. And as the denominator gets really, really large, as n goes to infinity, that becomes the actual probability. So the probability is defined as a limit. So if we think about this, if we flip a coin 100 times, we have a rough idea that we expect to get about 50-50, 50 heads, 50 tails, roughly. It won't exactly happen like that in real life, but we can guess that we'll have 50 over 100. If we flip a coin 1,000 times, and we should expect to get about 500 heads. So we're going to think we're going to have 500 over 1,000. Each time we get this expected sense of what will happen, we see the probability is about 1/2. And that sort of balances with our intuition what probability should be. So in future videos, in future discussions, we'll talk about this definition of probability in terms of a limit over the total number of events, where the number of events gets the number of experiments, or the number of events is very large. Thank you very much.